Hello. So, for the two questions that I decided to have this video on was question 1 and question 2. So, reading question 1, the number of students who go to Pullman from WSU Vancouver for a typical football game is normally distributed with a mu of 350 and a sigma of 25. So, first question, what is the probability that more than 400 students will be at the next game? So before we do that, let's go ahead and write our values. Oops. So we know that our mu equals 350. We know that sigma equals 25. And so we're going to be finding the probability. So we'll have to find z. In order to find z, we take our x, subtract our mu from it, and divide by our sigma. So in this case, for the first question, our x is going to equal 400. So z equals 400 minus 350 divided by 25. After doing the math, we know that z is equal to 2. And now we want to find the z-score. So we're going to go to this, a z-value of 2, which corresponds to a z-score of 0.0228. Or we could say that 2.28% of students will be at the next game. Moving on to the second part, what is the probability that less than 285 students will be at the next game? Actually, you know what? I'm going to take that back. Let's backtrack a bit. I just noticed that the second part is less than, but the first part is greater than. So once we know that the z-value is 2, that corresponds to a z-score of 0.9772. Now from here, we're going to want to take the complement of this, so we're going to do 1 minus 0.9772, and that gives us the 0.0228, or 2.28%. There we go. All right. So the second question, it's going to ask for what is the probability that less than 285 students will be at the next game. So our x is no longer 400. Our new x is going to be 285. So just like question A, we're gonna find the z value. We have 285 minus 350 divided by 25. And that gives us z-score of, or z-value of negative 2.6. And we go and find that on the z table, and we know that that equals 0.0047, or 0.47%. All right, for the third part, It's asking us what the probability will be between 350 students and 425 students who will go to Pullman for the next game. So for this part, we now have two new x values, 350 and 425. So we're just going to do just like how we did before. This is going to equal this is actually just going to equal 0, which corresponds to a z-score of 0.5. And this equals 3, which corresponds to 0.9987. So from here, we're going to want to take the larger z-value and subtract the smaller z-value from that. We're going to do 0.9987 minus 0.5. That is going to give us 0.4987 or 49.87%. All right, for the fourth part, we're going to see what the probability, or what is the probability that between 300 and 325 students will go to Pullman for the next game. So we're actually going to do exactly what we did for part C. All right, from here, we're going to take the 0.1578 and subtract the 0.0228 from that. That gives us 0.1359 or 13.59%. Okay, I'm gonna have to flip this over. Okay, so for E, it says what is the probability that there will be less than 325 or more than 435 students at the next game. So basically what we are going to do is we're going to do a very similar procedure as we did for part C and part D, except for this time around, we're going to keep the 325 just like what we did here. So we can actually just take this number and just put it as our first z-value. But for this number, we're going to do what we did in part A, which we're going to have to find the complement of that. So what we have here is a x value of 325 and an x of 435. So like I said, we can already go ahead and take this. All right, so that's our z value for an x of 325. Now for this, oops, minus 350 divided by 25. Again, it's the x minus the mu divided by sigma. That's going to give us z of 3.5, which corresponds to 0.9997. All right, so now since it is a greater than, since we're trying to find what's more or more than 435 students at the next game, we're going to subtract that from 1. I don't know why that's there. 1 minus 0.9997 equals 0.0003. Now from here, we're actually going to add this to that. So we're going to go ahead 0.1587 plus 0.0003. And that gives us 0.159 or 15.9%. That's question 1. All right, here we are, question 2. After talking to your friend Abby about her study habits, you decide to try to find the habits of students on campus to see how you compare. Historically, students tend to study about 180 minutes a week, with a deviation of 30 minutes. You decide to collect multiple samples at different universities. Let's go ahead. Let's go back and underline our important facts. Sorry about that. So you decide to collect multiple samples at different universities to find out. Each sample you collect has 25 students. What is the probability that the mean study time of a sample is? And here are our different questions that we are going to be going over. So we already know our mu is 180, sigma is 30, and we have a sample size of 25. So for A, we're looking at the probability that the mean study time of a sample is less than 171. So our formula for this is our z equals our x bar minus our mu divided by our sigma divided by the square root of n. So we can go ahead and plug in everything. All right, there we go. And as for the first problem, this is exactly the same. Trying to find the z-score in order to find the probability or percentage. Now let's move on to our second question. So we're going to have an x that is going to be greater than 160 but less than 180. So what we're going to do here is exactly what we did in A. Take our 160 minus our 180 divided by 30 divided by square root of 25. And over here we have a z equals 180 minus 180 divided by 30 divided by square root of 25. Let's go ahead and look at this. 180 minus 180 is 0, so 0 divided by, this turns out to be 6, is going to be 0. And like I mentioned before, a z value of 0 is going to give us a z-score of 0.5. Over here, our z becomes -2, which corresponds to a z value of 0.0228. And from here, we're just gonna take our larger z-score, subtract our smaller z-score from that, and we get 0.4772, or 47.72%. Okay, on to the third part. Oops, sorry about that. On to the third part. So we want to find out what the probability is when our x is greater, or when our x is 183 and is or when it is greater than 183. Sorry for the confusion. So our x bar this time around is going to be 183. We can already go ahead and fill out everything. Okay, now since it is greater, like I said, it is in the upper region. We are gonna have to take the complement of this. So 1 minus 0.6915 turns out to be 0.3085. Or 30.85%. Okay, now let's make some room for D. Now we're going to be looking at least 160. Our x bar this time around is going to be 160. Plug that in. Okay, now this is actually kind of tricky. It says at least. So it has to be at least 160. So when we're looking at this, it has to be at least, so we know that it's going to be an equal sign, or equal, like greater than equal, less than equal. So it has to be at least 160. And in order for that to be true, it has to be greater than or equal to 160. In this case, since it is a greater sign, we're going to have to take the complement of this again. And there we have that. Okay, and the last part of question 2, part E, we're looking at less than 160 or more than 191. So basically what we did here in question 1, we did the exact same thing as we did with the 325, which was the less than, and for 435, it was the greater than, so we had to take the complement, and we're going to add these two together. I'm taking that from the less than 160 or more than 191. Now we're going to take the complement, which gives us 0.336. I'm going to add these two together. Sorry about that, that's a bit sloppy. That brings us up to 0.034 or 3.4%. And there we have that. It's question 1 and question 2 of the second exam. Thanks very much.